Equm graphing notes. In the previous video, we were doing the calculations so we would have data to graph. So the data we're going to put in, we have these starting concentrations of the H2I2 and the 2HI. And then we had these values for their concentrations as it moved to equilibrium. Then we had a stress, so we're going to have to increase this. And we went through a series of calculations, and this was the set of new equilibrium concentrations, which become our starting point for C. So we see these numbers again. And then we had a temperature change. That was our stress, and we go until we have these concentrations. So now we're ready to turn this into a graph. And this is something you'll be doing. And I better shrink this down a bit so it can fit better on the screen. Oh, almost fits. It will go a little farther. Okay. So we have this graph, and you can see this is going to be concentration of the different materials in moles per liter. And so we see it took however long this was to go from the T's naught, that's where we started at T1, where stress is applied. So we had the HI going up, and it went up twice as far as these drop. The H2 and the I2 drop the same amount. This dotted red line represents the stress of adding 0.0500 mHi. So the HI spiked like so. That was the stress. And then we go to a new equilibrium. Since the HI has gone up, as it goes to equilibrium, it has to drop. We've got to use some of that up. And that means we're going to produce some more H2 and I2. Then we had the temperature shifting, and we saw the temperature being increased caused a shift in equilibrium to the left. And so we carried on with these kind of curves. And it happened the H2 and the I2 followed the same pattern all throughout. We didn't do anything, we didn't do an individual stress to one or the other. So things we want you to notice from the graph. This is always the curving pattern. Things are going to curve and the slope gets shallower and shallower until it flattens out, it plateaus. You don't draw it as a curve up like this, you don't draw it as a straight line. It's curving and flattening. This one's curving and flattening the other way. Slope becomes more gentle. Again, curving, flattening, always ending up with a flat. So this is what you'll run into a lot, where you start with just the reactants and you go to the products. This is what you'll run into a fair amount when you have a stress of increasing or decreasing the concentration of a material. And here we have a temperature stress where things curve. So get used to it. If you have a concentration as a stress, only one thing will spike or one thing will drop. Then you get the curving to equilibrium. When you have a temperature stress, there's no spiking, there's no sharp drop. Everything just curves to a new equilibrium. And we don't have it here. We had it in a previous video. But if it's a pressure change, everything spikes or everything drops before they curve to a new equilibrium. So that gives you a fairly precise set of notes on this. These numbers were not pulled from thin air. At each case, I have plotted the numbers that were indicated. So we can see these numbers were plotted. These numbers, 0.0864 and 0.00680. That's where these things were showing up. And then we got to see these numbers came after at this point. And then the final numbers, these ones, are where we ended up here and here. And so you want to do reasonably careful graphs when you get graphing questions like this. Hopefully that's making sense.